Welcome, viewers, to another edition of It Depends podcast. The pace of innovation in data and analytics has never been as hectic as it is today. I was just reading recently, IDC predicts 750 million new apps will be created in the next 2 years, which is more than the number of apps in all of the last 4 decades. I was also reading that the number of objects on AWS's object store S3 now exceeds 100 trillion, which is equal to 13,000 objects per human being on this planet. We are constantly being bombarded by new approaches, technologies, products, but some of us who've been around this block for a long time have a nagging feeling. Why does it feel like I've seen this movie before? Is this old wine in new bottle, or is this truly revolutionary? To answer that question, we turn to a good friend, Bob Muglia, who has been leading the data and analytics charge in the senior leadership roles at iconic companies, including almost 25 years at Microsoft, where he was the president of the server and tools division. With that, Bob, welcome to this show. So happy that you can join us.
Great, Sanjeev. It's great to be here with you.
Thank you. Bob, I cannot do justice to your rich background. Can you please educate us on how the journey has been for you up to this point?
Well, I think it's been interesting. I've been really building data and applications my entire career. When I first got out of college at the University of Michigan in 1981, and was focused on early databases and database applications, particularly ISAM and network-oriented databases, before SQL and relational became the thing that everybody was working on. My first real deep experience with SQL was when I took over SQL Server program management and was the first technical guy on SQL Server at Microsoft in early 1988. And helped to release the initial versions of that product. And then I've been involved in the database space in all of my time I was at Microsoft, and helped to really make SQL Server the product that it became, and to really establish small businesses in particular with automation and server systems that were able to run their business. After I left Microsoft in 2011, I spent a couple of years at Juniper, where I really learned a lot about networking and some of the ups and downs of networking. And then I was at Snowflake for 5 years. And since I left Snowflake in 2019, I've been working with a number of small companies, mostly in the data space, that are doing really innovative things.
Very nice. Bob, I have so many questions for you today. I'm very curious about some of these companies that you are working with. But before we go and talk about products and technologies, I want to ask you a few questions pertaining to the overall market. The first question I have for you is, what do you see as some of the biggest challenges in the data and analytics space today?
Okay. Well, we've come from a world where data was all distributed in silos. People had a really hard time managing it, and desktops really were the primary place where data was analyzed. And that was because you had to pull everything together, and it was really very messy. With the modern data stack, with the advent of cloud computing and the modern data stack, we've had the ability to consolidate all data in one place and enable people to do consolidated analytics across their organization. It still sometimes makes sense to separate these things into independent domains, depending on how large an organization is. But fundamentally, you can work with as much data as you want and make that data available to as many users simultaneously as you want. And that's a major innovation that happened in the modern data stack in the cloud space, which wasn't available before products like Snowflake or BigQuery. Now we're kind of getting past that, and people are moving in that direction. The interesting thing is, once you pull all the data together in one place, you have a governance issue. You have a brand new governance issue you have to deal with. In some ways, it was hard to get at data. Data was in some ways secure when nobody could get at it. But now that it's very accessible to people, you really have to manage that information and who has access to it. I think there's a lot of challenges there. I think the industry is pretty nascent still. When I look at what people are doing with machine learning, it's still obviously very early in those spaces. And there's a lot of changes that I think are going to come in machine learning and really working on predictive analytics against data. And ultimately, what people are doing is they're building these next generation data applications, which really are built on top of the analytic data stack and they respond to changes in data. If you think about every application that you use on a day-to-day basis, those apps are designed to work with people. They,
Yeah.
you go to a website and you buy a ticket to something, you purchase something, you do an email. Apps are designed to work with people. These new generation of apps are really responding to data that is happening, and they're taking action autonomously or independently based on that data. And they're doing things in essence ahead of what people could do, and are making predictions on things. So it's a whole new generation of apps that are being built.
How are the challenges different from when you started your career in 1981?
I mean, it's almost interesting to say, how are they the same? In some ways, things are so different. You know, I mean, back in the 80s, everything was done through distribution, and you had to work. Everything was on premises, of course. The first version of SQL Server I shipped had 72 floppy disks in it. Okay, that just gives you a crazy idea. I mean, obviously that's insane. It maybe could have fit on a CD-ROM, but even so, you think about it, it had 10 pounds of manuals in there, 12 pounds of manuals. And there was a physical production process. I remember going to literally Microsoft manufacturing to manufacture the box. And it's sort of a crazy thought these days, because everything is a service and everything is dynamic. It used to take years when I was at Microsoft for product feedback from customers to be incorporated into the product, and then deployed by the customer and have that available for use. I mean, we measured it could take 4 years from the point where a customer gave us a piece of advice until they were able to use it. I mean, it might have only taken us 2 years to get it out, but then they don't deploy it for 2 more years. Whereas we were able to, at Snowflake, we were able to take customer feedback and deploy solutions, new features, sometimes in just a few weeks or even a couple of days if it was a very small change. And you could do major things in a few months. And that was never possible before. So the world is very different with services today, and it's services that's changed it.
Yeah. And so what are some of the key inflection points when we see the world changing?
Yeah. So, I've lived through a lot of them. I mean, when I first started working, I was working on mini computers predominantly. And they're big backbones, and very few people had access to it. My career at Microsoft was really about taking and making computing ubiquitous for everyone. And in particular, on the business side, that's where my focus primarily was bringing computing to businesses of all types. And back in the 80s and early 90s, small businesses were using pencil and paper on everything. So a key inflection point was the PC and networks of PCs, and then servers against that. That was happening in the 1990s. The client server sort of era was a big inflection point, because that was the beginning of the automation of the breadth of businesses. The internet, which is sort of the latter half of the 1990s, brought with it the ability to access information remotely, and brings with internet commerce, all sorts of new things were created through the internet. But it was this combination of local servers together with the internet deployment that really enabled many businesses to begin to move into the computing age. And now, of course, with services in the cloud, that's another major inflection point, because everything's moving, or many things, and maybe not everything, but many things are moving off of an on-premises environment into cloud deployments where they can be managed centrally. And a lot of the sort of expectations and historical viewpoints are being challenged. Like, there's been a viewpoint that on premises is more secure than in the cloud. And that's not, it's certainly not generally a true statement. It may be possible for a given organization to provide incredible security, but by and large, it's pretty clear that by centralizing things, you can actually do better overall and provide a better experience.
Yeah, I agree. Bob, I remember when I started my career in the 90s and I was working for Oracle, if we ran into a bug, we had to replicate that bug on a DEC VAX VMS machine because Oracle's base code was built
Ran on
on,
that.
on a mini computer. And if we could see the same bug on a DEC VAX machine, then we knew it was a base bug and not a bug on a port. So, yeah. So it
No,
seems
it's true. Those are the kinds of questions you had to do. And of course, just
Yeah.
replicating the problem could take months sometimes.
Yes, correct.
You know, whereas one of the things that was remarkable, and you know, this was something that we did very well at Snowflake, was the telemetry you have to tell you what's going on is remarkable in modern systems. And Snowflake ate its own dog food with this. We took all of our telemetry data and put it in Snowflake.
Oh, wow.
And so literally every single customer interaction began with a query against the database. And so when product support got an issue, they would start looking at logs, you know, and they were running SQL queries to do that. And then if they found something that looked like it was an engineering issue, it would go to the engineering team, at which point they would run their SQL queries to find out their stuff and all the more detailed information they could get to as well. And that's remarkable because you can most of the time understand what's happening in the system without having to re-replicate the problem because the telemetry can provide you with that.
This is fascinating because, you know, Grafana has been a great visualization tool that used Prometheus, and I'm now starting to hear that a lot of that telemetry is now being put straight into Snowflake rather than Prometheus, and people are using SQL on top. In fact, data observability is a great use case of that.
Yeah, I mean, when you have a data warehouse that can work with terabytes and terabytes of information, and particularly combine information together, it's quite useful for debugging purposes.
Yeah. So, Bob, we've talked quite a bit about challenges, present and past. Let's talk about solutions next. What do you feel are the most promising technology that will help transform businesses faster?
Well, one that is new, that is really, I think, having a major impact right now, beginning to have a major impact right now, and will have a major impact, are these new foundation models that are coming out. Things like GPT-3, Codex, DALL-E, things like that. There are many of them. It turns out there are quite a few of them being developed. And what these really are, I mean, sometimes people call them large language models because the initial ones worked with languages, but that's just a category in some ways of foundation models. What they really are is models that have been pre-trained on a very large amount of content, essentially on the internet level of a given domain, or as much information as possible. And what is happening with these things is that the techniques, the probabilistic techniques that are being built into these foundation models are enabling you to encapsulate a fair amount of information and across a given domain, and actually create what you can think of as world experts in something, and enable people to have expertise distilled into these systems that can then be leveraged in other ways. And it's very, very exciting. It's a very exciting thing. In general, what I would say is the trend that I think we'll see is a world towards modeling in general. And you know, the other type of modeling that I think is really interesting is what I might call explicit modeling, and the creation of knowledge graphs, where you encapsulate business knowledge directly into a system. And one way to think about it is trying to think about different ways to explain this to people. But I think the way you can think about it is we've always been modeling in business. And I mean, I look back when I went back in the 1980s, you know, one of the things that was in vogue was to actually use tools to model the business and then attempt to write some kind of code associated with it. And of course, that didn't work because the code was unmaintainable, and people have moved away from these tools because all they really is a way of visualizing a business process. And instead, people use whiteboards, or they use Slack, or they use whatever. But there is a model. There's always a model, and it's kind of implicit. I think of it as an implicit model in the business, and it's typically encoded in business rules in Java and SQL, and it's placed in a bunch of different systems. It exists, but it's not stored in one place. And, you know, one of the trends I think we'll have is towards modeling in general, more explicit modeling, where we define explicitly what the business rules are. And that is, you know, that's in the form of what people often talk about as knowledge graphs. And I think relational technology will rule in knowledge graphs, just like it's ruled in databases. So I think a major trend will be towards relational knowledge graphs to directly encode business rules into a database, in essence, that can manage the business and have an explicitly defined model directly. And it becomes, the model becomes the program in that world.
Yeah.
And then the other thing that I think is really interesting, all these machine learning models are really learned models that are where it's looked at the history of something and it's learned something from it, and that can be applied to the business. So I think we're moving at the macro, I think we're moving from a world where modeling is done, but it's implicit, to a world where it's either explicitly performed within a system or it's been learned based on past history.
Oh, wow. You know, I just saw today, coincidentally, OpenAI had a very restrictive option for people to download their models and use them for beta testing. And today they removed that restriction.
It's great.
Because they're saying that we have now learned, we have built our systems, so now we are capable of handling any request for people who want to use OpenAI.
So there are a lot of challenges, obviously, to these learned models, because they learn from whatever they're learning from, and not everything is good they learn from. So they behave, sometimes they behave randomly for some random probabilistic reason, and sometimes they behave poorly because they've been trained on data that has undesirable characteristics in it. And part of the challenges people have is making sure that those things don't expose themselves, particularly in consumer-facing sort of models.
Bob, we've also seen lately for the last couple of years, there's been an explosion of new startups addressing micro segments of the data stack. Why is this stampede to start new companies?
Well, there's a lot of VC money on it. I'll start by saying that the VCs are funding it pretty aggressively, and they still actually, in a world where, you know, the conditions in 2022 are not favorable right now, but that is an area that continues to get some reasonable investment from venture capitalists. I think because there are problems, right? I mean, I think what's happened is that when we moved from a world where people had data scattered all over the place to a world where data was centralized in a single analytic database, or data lake, whatever you want to call it, that exposed a set of issues. A lot of these issues around governance, performance sets of issues, understanding and doing the data modeling has been with the new rise of tools like DBT. So there's a bunch of products that have risen to fill the gaps that exist in these systems. There's a challenge in that, though, because the current generation of products that support the modern data stack don't interoperate particularly well. And they all, one of the fascinating things is that when you look at any one of these products, they tend to have some kind of proprietary store that they're using, that they keep their metadata in, and that's locked into their space. It's not really a shared environment. And it's interesting that the tools that are being used around the modern data stack in general are not being built on the modern data stack. And the reason for this is because when you begin to work with the metadata associated with data, the relationships associated with that metadata become incredibly complicated and exceed the conceptual complexity of what you can efficiently do in today's SQL databases. So you literally can't run the queries you need to run on a Snowflake or a BigQuery. And unfortunately, the current generation of databases don't really support these solutions particularly well either. The graph-oriented databases, which one might turn to solve some of these problems, are based on navigational approaches, similar, frankly, to what I was doing. I mean, they're not the same, but they have some similar characteristics from a programming complexity perspective to what I was dealing with when I was working with network databases in the 1970s and the 1980s. I mean, they explicitly store links between nodes in the graph. And if you think about the nature of analytic problems, they're an ad hoc problem. The most interesting questions are the relationships you never thought of asking before.
Yeah.
And it's just not feasible to build a system that pre-calculates all of those connections. It turns out you get to more atoms than in the universe sort of things if you look at the full complexity of some of these models. And so you need to do those things to calculate the relationships between those things dynamically, which requires you to move to more relational architectures. And the current generation of SQL databases are built on algorithms that are literally 40 years old. And that's true. I mean, you go back to DB2 and the early Oracle, or you go to Snowflake and BigQuery and Redshift, they're all built on similar algorithms of a binary join. Where you take this table and this table, you join it together, your result set, you take and do that. That's just inefficient on some of these complex relationships, particularly if recursion is involved. And we need new algorithms. And it turns out the algorithms have been built. And there's a whole new generation of exciting relational algorithms called worst case optimal join algorithms that enable you to solve some of these super complicated problems. But the products are early. It's still early days for that.
So, Bob, we are going to talk more about graph databases because one of your companies that you advise is Relational AI, and very interested in talking more about it. Before we go into the products, I want to go back to something you just mentioned. You said, in the current market scenario, that is a fascinating topic because last year, companies were getting a valuation of 200x by VCs. And this year, as I was preparing for this podcast a few weeks ago, I started writing my notes that valuations are down to 5 to 10x. But 2 weeks ago, Figma got snagged by Adobe for $20 billion at 40x valuation. So what's going on in this market? I mean, when I saw the Figma acquisition, I was like, oh, wow, is the tech industry back in favor now? Where do you see this industry in the next 2 years?
Well, first of all, I think if I went back to a year ago, I think the valuations were crazy. I mean, I thought they were crazy in the second half of last year, and I think as is often happens, the market got a bit overheated. That said, it has reacted. The pendulum swung rapidly and hard, and we're now in a very, very bearish sort of mode of the market, as bearish as I can recall. I mean, it's we're in the 2008 sort of style market bearishness, and we may, unlike 2008, which lasted about 2 years, 18, 24 months, this may last longer. So it's not clear. It's a tough market we're in. The Figma thing, I would treat that as a one-off personally, because you always have these companies that can occasionally you have a situation where a company can demand a very high valuation from a given company because the sum of 1 + 1 = 4 or 6, in their perspective.
11.
Adobe had a big need.
Yeah.
They had a problem, they solved it. It's similar to the WhatsApp. If I kind of go back when the WhatsApp one, which was when Facebook acquired that was the only company on the planet that would have paid that amount of money. But they were, they would pay money.
Yeah. So it seems like the buzzwords are now not even SaaS anymore. It's PLG, product-led growth. I hear that every so often, but we're not going to go into that space. We're going to stick to the buzzwords that are obligatory to bring up in every event and every talk, and those are data mesh and data fabric. What are your thoughts on this, and also related topics like data products or data as a product?
Well, let's start with it because they're fairly different. And people, data mesh and data fabric sound like the same thing, but they're actually quite different in some sense. Data mesh, is a set of concepts and ideas around domain-oriented creation of data systems and treating those data systems effectively as products that you release to other parts of your organization. I think that's, when I think about how to structure a large data-centric organization, whether it's a big tech company or a very large data-centric Fortune 500 company, maybe a bank or something like that, the idea of doing domain-based ownership of data just makes sense. It's the right idea. You can't have a single central organization for Citibank. I mean, it's just not rational. It's too big of a company and too many different businesses and things like that. And so you need to have domain ownership of data. And the right way to treat that is that data is a key asset and it is a product, and you treat it as a offering that has major meaning to your customers, be they internal or external. And many of these customers start with internal. Many of these situations it's internal, but then they begin to say, well, I can monetize the data potentially by offering it externally as well. And so they have interest in that as well. And certainly that makes sense to be domain oriented and data as a product. And to me, that's the foundation of data mesh, and it's just basically correct. Sometimes some consultants sometimes go off and they talk about different implementation approaches to data mesh. And to me, what people should do is use the modern data stack and the tools that are part of the data stack to implement a data mesh. And it's certainly true that with products like Snowflake or BigQuery, you can do that. I mean, when we built Snowflake and we built the data sharing capabilities into Snowflake, we built all of those capabilities. We actually built this thing, they believe they call it the data exchange, which is an internal way of sharing data within your organization. That is a way of building a data mesh, period. And it's a technique that you can use to build a data mesh. And again, a data mesh is an organizational concept of how you manage data and how you treat it. And then there's different implementation approaches. And to me, you can build it on the modern data stack. Some people talk about using streaming and all sorts of complicated things. And that may make sense if you're a big tech company in Silicon Valley. But it's a very rare case where I would think that would be appropriate. I would adopt the tools that people are adopting across the industry, whether it's Snowflake or BigQuery or Databricks or whatever it might be, Amazon, Microsoft, whatever they're using, Synapse, adopt their core platforms and then leverage it for some of these concepts. So that's the data mesh.
Yeah.
And again, I wouldn't get too confused about the technology underneath it.
Yeah.
I would focus on the organizational aspects of it. The data fabric is a concept. I mean, I think Gartner is really the one that's pushing data fabric, and really it's the next generation. In a way, I think of the data fabric as the future of the modern data stack, as envisioned by Gartner, which is pretty meaningful. Okay, I'll be honest with you. Gartner is pretty meaningful in this space. And what I really like about the data fabric, as Gartner is talking about it, is that it's correct. I mean, at some level, it's a correct way of looking at the problem, and it's at 100,000 feet. So it doesn't have you any implementation guidelines. It doesn't tell you how to do it. It's at 100,000 feet. So it's an architectural direction. And really, it's this idea that you move from having just all your centralized data to centralizing your business policies and your business logic and your business rules into a common system that can be managed cohesively. And that's the core concept of the data fabric. And I'm 100% on board with it. I'm also 100% clear that we're not there yet. That the tools are very poor. Yeah. I mean, that I don't know that anyone has built what I would consider a successful data fabric today. And I'm not even sure how I would, I mean, if I were like, the head of data for some company, I'm not even sure what I would do to do it. Because one of the key components of the data fabric, as defined by Gartner, and I agree with it, is a knowledge graph.
Yes, correct.
And we're not there yet. We're just not quite at the point where the systems support the knowledge graph. There really isn't. I mean, there are a few products that do knowledge graph, something with knowledge graphs, but I really believe you have to build this like we built Snowflake from the bottom up and design a system that was designed to be a knowledge graph management system. And that's that's still coming.
That's very interesting that you're saying that, because I see you as being at the forefront of graph technology and really doing a lot of research and education. So if you think that knowledge graph is still in early stages, that's quite telling.
It is. I mean, look, you can't go out and buy. find me successful knowledge. I mean, just find me half a dozen customers that say I've built a successful knowledge graph. I mean, just find them. I mean, they're very hard to find. I mean, and I mean, I can find 100 customers that have built successful deployments on Snowflake. But what if you find things that solve some material problem this way? They're few and far. I mean, I'm going to say they don't exist, but they're few and far between. And we do have knowledge graphs, by the way. Knowledge graphs exist today, but they're in places like Google and LinkedIn. And they're custom built, right?
Yeah.
Right, they're custom built. And in fact, in knowledge graph, when you query, when you query a restaurant, I was querying restaurants yesterday in Google, and you get the little thing off to the side that says, that shows you the picture of the restaurant. That's a knowledge graph. I mean, that's the Google knowledge graph doing what it's doing. But try buy that. I mean, you can't go build that yourself, right? That's a bunch of Google stuff.
Yeah. Wow, very interesting. And then what about data products? There's so many terms being thrown around these days: data contract, data products. What are your views on data product?
Well, I think thinking of what you're building for your constituents as a product is the right viewpoint. I think that's the right way to, whether you're working with internal analysts, internal data scientists, or you're trying to monetize and sell data in some form. I think thinking of it as a product for every data team is important. And by the way, we talked about this domain orientation in larger companies. Again, that's for larger companies. I mean, if you're a 100-person company and you have 3 people in your data team, you don't have domains, right? You have one team, and that only makes sense. If you have 10,000 people in your company and you've got many different businesses, then it makes sense to go to a domain-oriented architecture. In either case, though, it makes sense to think of what you're doing as a product and offering that either to internal customers or external customers. Yeah. And so I think that's the right way to think about it.
I see. So Bob, I have 2 more questions, and then we'll change tracks. There are 2 parts. So the first part is, what do you think are the most underrated technologies and hence have a great future potential? And converse of that, what are some of the most overrated technologies that are more hype than substance?
Well, I think that where we are right now, I mean, I think the machine learning may be both in some senses. We're in this situation where the impact that machine learning is going to have, I mean, this is always true of new technologies as they begin to emerge, is that it's hyped, it's overhyped in some senses, it under delivers. I mean, it's the Gartner hype. The Gartner hype curve is very real, right? I mean, you tend to go through these periods of over exuberance and then the trough of disillusionment in technologies. And in some ways, we may be in some senses in some areas in disillusionment on machine learning, but the actual value associated with these technologies is going to be tremendous, and it's going to have a gigantic impact on almost every business application. In fact, I think that the 2020s is the era of learned models. Let me say it that way. And it'll begin to be the era of explicit models. I mean, we're moving from implicit modeling to explicit and learned modeling in this period. And in some senses, people just don't understand how important modeling is to everything. And so machine learning is really a form of modeling, and really everything we do in business is also a form of modeling. And we're moving to a world where the systems will be able to do more of that for us versus us having to build it in these complicated ways that we build it today. It's really bizarre. I mean, we build systems. The way people build systems today it's very complicated. You think about deploying something on AWS, it's great, it's fantastic, but boy, there's a lot of moving parts.
There are, yes. And AWS and other cloud providers have done an amazing job of providing us with over 200 different services, but not the glue, the connectivity tissues, so now you got hundreds of services with their own IAM policies and their own.
It's very complicated.
Yeah, it's complicated. Yep.
It's gotten more complicated, not less, to be honest with you.
Yeah.
It's gotten easier. It's gotten easier because you don't have to physically deploy this stuff. You don't have to roll out computers.
Yes.
Stuff. But it's
operational side is so much better. Like you said, like imagine creating, you write the software, the developers write the code for SQL Server, then it goes into the manufacturing where now they're burning CD-ROMs and floppy disks. And I mean, imagine all of that is history. Now, we get an update on an iPhone in like every day.
It's much better. This is what's really changed is these things have become, I think back to I don't know if people remember, Walt Mossberg used to write a piece in the Wall Street Journal about consumer electronics and all the things he complained about with PCs and stuff. And I really think about, this stuff's mostly been fixed. It's mostly been fixed.
Right.
These things are truly consumer devices now, and they maintain themselves.
Bob, I still have a question about models, because one of my passions when I was young in this data management space was creating ERDs, enterprise relationship models. So creating that data model was how I would tell the story for a bunch of these websites that we use today. How would you classify ERD as a model? Implicit, explicit? What would
you're trying to be explicit there, right? You're trying to be explicit there.
Right.
But what happens then is that you write this thing. I mean, this is a classic thing. Whatever you did, it gets handed to a bunch of developers, right? And then it never gets updated. The implementation moves on. Right. And the model is left behind. And I mean, who really updates those models? I mean, somebody does someplace, but it's not it's few and far between. Let's put it that way. And it's because it's simply a picture, right? It's simply a drawing. And the real implementation is the code. But what if the model was the code? In a way, that's been the holy grail dream since I started in this industry in the 1970s, is that you could define and that's what they tried to do in the early modeling tools, which did code gen. They literally generated COBOL code, which, of course, was unmaintainable and didn't have the full semantics. And in order for a model to be executable, it needs to support the entire domain of semantics that are required for that application. If there's any semantic that cannot be handled by the model, it has to be handled externally, and you've sort of blown it. And if you look at the mathematics associated with what people have done, we've never had the math yet. We've never had the algorithm designs until recently to create executable models. And this is where I think the relational knowledge graph comes in. Because what's happened is that because of fundamental research in relational technology that's been happening at universities around the world over mostly the last 10 years, there's a whole new generation of join algorithms that are much more efficient, these worst case optimal joins, which are essentially a multi-way join. I mean, it's so obvious if you think about it. It's just, when IBM first designed the binary join, because they did it as a part of System R and DB2 in the 1970s. I mean, how much memory did that thing have? It had like 8K of memory or something they were running in. So they had a table and another table, and they did a join, and that's how much memory they had. Now we've got gigabytes of memory. Why can't we join multiple relations simultaneously? And the interesting thing is that with modern worst case optimal join algorithms, the more relations you add, the faster it goes. It's exactly the opposite in a traditional SQL database. The more joins you do, the slower it goes. Joins are deadly in SQL, and you can't do 100 joins in a SQL query. But with these new algorithms, you can. And then it allows you to advance the optimization that you do. Today, optimizers in SQL. What is SQL? SQL is a query language that is translated into relational algebra statements that are executed in order by the system. And the data optimizer, the database optimizer, the query optimizer translates those SQL statements into these relational algebra statements. If we go back to COD and COD's theorem, that relational calculus, which is a declarative way of defining what you do, is equivalent, semantically equivalent to relational algebra. It's very important learning that came from the 1970s and COD, but somewhat been forgotten. And now with the new type of modeling that will be done using relational knowledge graphs, will use effectively relational calculus statements where you have declarative statements of what your intent is to do. and the full algorithm can be expressed. The entire mathematical algorithm can be expressed. What you would normally do in Java or Python, you could now do inside the database, but you declare what you want to do, not how you do it, not the order you do it. And these relational calculus statements are unordered. They're just statements of truth. This, salary equals, total comp equals salary plus blah, 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 blah. It's the total statements of truth. They're statements of truth that are put inside the database. And the optimizer has the full semantics to be able to decide how to execute those. And that's what we kind of need, because when you start to work with huge amounts of data, the system is better able to optimize that and better able to optimize the algorithms that are applied to that than people typically are. And so you can get dramatic improvements in performance because of the fact that you're optimizing it across the full set of data that you're working on.
Wow, this is fascinating. In fact, I think it's time for us to talk about one of the companies that you advise. I know you advise maybe half a dozen different companies. One of them is Relational AI. Can you tell us more about what does Relational AI do and what attracted you to this company?
Yeah, I mean, Relational AI is the company. I mean, when I've been talking about relational knowledge graphs, this is the company that's driving this. And this is the company, Moham Arif is the CEO. He's been really driving the work across industry, across universities. He's been working with 20 universities across the world and well over 20 researchers that are building these next generation algorithms. All these algorithms have been built they're all papers, they're all released as papers. This is, by the way, the way SQL has always worked, is that you write papers, the database experts, they write papers about what can be done, and those papers are adopted by the industry and the algorithms are incorporated into the products. Well, there's a whole new generation of algorithms that is befitting a new generation of database, this relational knowledge graph, which leverages relational ideas, but takes it to this next step because it incorporates code together with the data in the database and allows, and effectively, it's a way of doing very explicit modeling of your business. So with a relational knowledge graph, for example, if you are thinking about a marketing funnel, you declare all of the elements of the funnel in the relational knowledge graph. And you allow the knowledge graph to calculate the results. So versus having to do a number of this off to the side and have external concepts and things, they all can be encoded in the knowledge graph. And so the expressiveness of these systems is dramatically greater than the way we do it today. Today, to get that expressiveness, we need to go back to that implicit approach of modeling where we put the code in Java or we put it in Python or Go or whatever, wherever across the different apps. Here, it can all be incorporated together as declarative statements that the semantic optimizer decides when to execute. And that gets back again to this theorem of Codd from the very beginning of relational.
So graph technology, just pure graph, not even knowledge graph, it's been around for quite some time. And I remember in Gartner, every year we said, this is a year of graph databases taking off. But over every year, I see the adoption has not been as much as we expected. Why is that?
Because they don't work.
Oh my God.
No, I mean, the challenge with today's graph databases is they do work. They just don't scale very well.
I see.
And they're hard to program. And the reason for this is because, and this is so fundamental, is they're navigational. They're built on they're not built on a relational foundation. And the problem, I mean, if the problem you're solving is an operational problem where the relationships are explicitly defined and consistent over time, maybe that's adequate. But when it's still tough to program for the same reasons it was 40 years ago, tough to program. It's still tough to program, but it may be adequate from a scale perspective. When you're now trying to deal with an analytic problem with large amounts of data, and the questions you're asking are not questions that you can predetermine ahead of time, navigational graph is just inappropriate for it. Because the questions you're asking now have to be, it has to just go through and figure everything out, and it's not very, and people have to write, and sometimes people have to write Java programs, for goodness sakes, to get these graph databases to do what they want them to do, or they're writing very complicated procedural logic to try and navigate the graph. again, the requirements of the level of knowledge of people are very high, and the performance characteristics are not so good. So it's pretty fundamental in today's graph databases. And again, what I think is going to happen here is what's happened in databases historically, which is relational wins.
Mhm.
You know, once relational reaches a point where it can replace whatever was done before, it always tends to win. And you know, classically what happens is you have a problem that the relational algorithms aren't up to solving. That's what we were in the 1980s, and that's why we used to have these networking and hierarchical databases. Once relational solved that, you know, then those typical business problems got replaced by and large with SQL systems. Now we're at a point where there is a generation of problems people have, and they're very much there. I mean, I was just talking to a large customer yesterday who was also saying we've got graph everywhere. They literally said this is a year. You said this is the year of the graph. For them, this is the year of the graph, because their problems that they're dealing with right now that they can't handle are graph problems by and large. Because they're a big Snowflake customer, and if SQL can handle it, they're already handling it, no problem. And so the things they can't solve tend to be graph problems, and the existing products they're struggling with, and that's why they're working with relational AI, because they can work with the data relationally, which is what they really want to do.
What are some interesting use cases of relational AI that you've come across?
You know, they're everywhere, really. I mean, essentially any complicated business problem that is poorly, if it's a simple enough logic and you know, you apply a SQL database to it and it works, great, just do it. It's easy. But you find, what we're finding is there are a whole host of problems people have that they can't solve. First of all, really complicated reasoning tends to be very difficult too. If you've got a really complicated business process, what happens is the reasoning associated with the logic, again, we get back to this implicit thing. It's somewhere, some of it's in Java, some of it's in SQL, some of it's over here, some of it's over there. And making all the pieces fit together is very difficult. You know, as an example, one of Relational AI's earliest customers is one of the big audit firms.
I see.
And you know, they do tax auditing on very large corporations. And you can imagine the complexity of tax auditing for a Fortune 100 or Fortune 500 company. I mean, it's crazy, right? I mean, the rules, all the million, and they're operating in all these governments around the world. I mean, the logic is very complicated. And they had a program that was a very large SQL Server program with a big C# front end to it, and a Microsoft shop, and so they had a huge SQL Server and a big C# program. The C# program was like 800,000 lines of code, and they were able to, with Relational AI, replace that program they replaced SQL Server and the C# program with one relational knowledge graph, which I think was about 10, 12, maybe 15,000 lines of relational logic. The language is called REL, and you write these declarative relational statements. And the biggest difference is that not only did it go from 800,000 lines of code to 10 or 15,000 lines of code, so a massive reduction in the amount of code that was written. But the biggest difference is that that the business analysts can look at these REL statements and say, that's correct. Yes, that's our logic, because the statements are, again, they're declarations of a business rule. They're not some random, you know, a variable being set against a table. You're actually dealing with business structures that have been defined in the database and defined at a level of detail that is more akin to what a business analyst would think of. They're metrics, for example. I mean, just think about metrics in databases today. Where do metrics live? Locked inside some random BI tool, right? I mean, that's where they are.
Correct.
And yet metrics are fundamental to the business. And that code for a metric might get defined inside Tableau, but it's also defined over here inside some Java program. I mean, is it the same? Who knows? By doing these things, you can do them once, you can do them consistently, and you can do them correctly. And the other thing is that, again, the performance can improve massively. You know, I first got interested in this there was a question you asked me is getting this.
Yeah.
I first got into this when I first met with Molhem, and he talked about machine learning and the future of machine learning and what happens when machine learning moves from linear algebra to relational algebra and how different that can be. And it struck me because I was watching, I didn't, when I was at Snowflake, many of our customers, and this is still true today, many of our customers use Databricks. And even more so, people are building business apps that use data frames that are essentially data frame-based business apps that are written on some Spark-like architecture. And this, all of this machine learning logic is incorporated into the Python code or whatever that's inside these data frames. And I would look at this and I would say, this is just strange to me, because you have all of this data inside a relational database, and there's all this information encapsulated in these relations between objects, and you lose all of that when you flatten it into a feature table. So what do people do with machine learning? They run these, if it's the data is originally in a relational database, you run these queries against the database that build a feature table that is essentially a two-dimensional, table that can be analyzed using linear algebra, and it's a lossy process. I mean, there's data that is lost that was present in the relationships that is no longer present in the feature table, and even with that, the feature tables are often larger that are created than the database itself. So you run these massive queries on the database to build these gigantic feature tables. And then you throw insane amounts of compute at these feature tables to perform your machine learning and build your model. And I would just look at that and go, something is missing. I don't know what's wrong with this, but something's wrong with this. And what Molhem explained is it was an algorithmic issue. And the issue is that the algorithms that people are using today use linear algebra, and they operate in these two-dimensional spaces. And you can use you can go to relational algebra and relational calculus to define these things. And now you have the dimensionality of the relational model. And the interesting thing is that in some cases, if you move from this process of taking the data out of the database, building a feature table, running the machine learning, you can get a multi-thousand time improvement in performance by doing it inside the database itself, because there's so much wasted energy. There's just so much waste associated with that. And the real issue is that if you look at what you're doing in machine learning, they're micro aggregations. You're aggregating, you're doing tens of thousands of small aggregations with the data, and that's creating the probabilistic information that's stored in the machine learning model. A SQL database can't handle tens of thousands of aggregations, but a relational knowledge graph can. And that's where you start to see some of the potential of this stuff, is that by moving the work into the database and operating using the relational model, there's just tremendous advantages.
Yeah, the practical examples you gave are just mind-blowing. And, so Bob, we can spend the whole episode on just, digging into this, because I have so many questions. But in the interest of time, I'm going to move to some of your other companies that you advise. Fivetran is one of them. Can you tell us what's your role and what attracted you to Fivetran?
Well, I'm a board member of Fivetran, and I've been on the board since early 2020. I've worked with George and Taylor since early 2015, when they were, I think, our first partner at Snowflake. We had two initial partners, Looker and Fivetran. I never remember which one was first, but those were the two that we went to market with. And Fivetran pulled the data out of a bunch of SaaS applications and databases, and then Snowflake was the data warehouse, and Looker you could use to analyze it. Back then, Tableau wouldn't even return our phone calls. It took a couple of years for Tableau to talk to us. They eventually did, and they became a great partner, and they're a great partner for Snowflake today. But so I've been working with Fivetran for a long time, and what attracted me to Fivetran, besides the people, because I do love the people, is that they got it right. If you look at the ELT world, it was people were pulling little bits of data from Informatica, using tools like Informatica to pull small amounts of data out of operational systems and put it in data warehouses. And that was completely correct. It made total sense in the early days with Teradata and Netezza, et cetera, because these data warehouses were shrines. They were the most expensive computers that were running in the data center, and people didn't want to touch them as much as you could. And so offloading anything you could off of those data warehouses makes sense. Well, Redshift in the cloud changed all that. And the early days of Fivetran were really Redshift days. They were working with Redshift before they started working with Snowflake. And because of the cloud and the economics associated with the cloud, all of a sudden the data warehouse becomes the least costly place to do these transforms, or certainly amongst the least costly. As the idea of moving all of the data out of the operational system into a staging schema in the data warehouse made sense, and then doing transforms on it. And the Fivetran was really the first to do that. The other thing Fivetran guys got right, which I had learned was very important over my days in working with at Juniper in the networking world, is that the Fivetran algorithms were idempotent. So they were self-correcting. So if one of the biggest challenges you have with loading data is when you screw up the data load and you mess up the database, you're in a really rough situation to recover from it. And with Fivetran, those things automatically recover. The nature of the algorithms automatically recover, which just makes it much more reliable. And that's one of the reasons why it's important. We recently bought HVR. There was an acquisition of HVR about a year ago, and that's been a fantastic acquisition. It's gone really well. HVR had done incredible work on understanding the binary format of on-premises databases, particularly Oracle log file format. And that's just a tough thing to do. That's just somebody doing a real hard piece of work. And that was it's fantastic to have that. We now have a world-class binary log readers, and Fivetran as a result can now span from the smallest companies that need a data warehouse to the largest enterprises on the planet that have some of the highest data needs, and it puts them in a really
that's great. So 3 more companies I noticed you invest in, and we won't have time to go through all of them. Fauna DB, Julia, and Dokugami. Fauna DB comes to it's something that's close to my heart because I cover DBMS space. I've been in this space for a long time, and it's a highly distributed document relational database, asset compliant with API only access, so no SQL. What's your view?
Works with in today's world, there's structured and semi-structured data for business, for operational applications, and SQL is the world of structured data. Semi-structured, you typically think of tools like Mongo to use it. Fauna is really a next generation globally distributed database that allows you to work very effectively with semi-structured data across multiple data centers around the world in a real cost-effective way. And I just see that, I think that's a lot of the future of where things are needed. And the idea that you have a globally distributed environment and you can use multiple data centers in different regions, I think is going to increase in importance over time. And Fauna has some unique capabilities because it's built on an algorithm called Calvin, which does not require clock synchronization. One of the challenges you have with most globally distributed databases is that the physical clocks in the servers need to be synchronized in order to get low latency transaction performance, and Fauna doesn't require that. So that's a pretty big advantage because only Google can really provide true clock synchronization. So it's a challenge. That's why that algorithm came from Google Spanner, and they were able to solve it with true time, but nobody else has done that.
Correct. Fantastic. It's been great. So Bob, in the few minutes we have left, so I'm going to change tracks here because I'm really curious to see what lessons have you learned from your illustrious career, and if you were to do things differently, what would you do?
Well, I think one of the main lessons is to learn from your people. One of my biggest mistakes is when I've pushed on something and it doesn't go somewhere. I have learned that there's a reason for that, and I should stop pushing. and usually, quite often the reason for it is that the timing is just not right, and the team is just not ready for something. It's not like it's wrong; it's just the timing is wrong. But one of the things I've learned is to really listen to the teams and to make sure that they're completely in sync with what you're doing. The classic thing is, this is the classic, and this is an old Microsoft sort of joke, is that you would go to an engineer and you'd ask them to do something, and it's 3 months work, and then, for some reason, something happens, and you come back on a Monday and the work is done, and it got done over the weekend. And how did it go from 3 months to over the weekend? And the answer is the engineer wanted to do the work versus not wanting to do the work. And to some extent, it's not just a matter of wanting, but my point is that when things aren't going the way you want them to go, respond, move more quickly and think about what the alternatives might be. Listen to your people and try and do the right things is what I would say.
I see. So we talked about a number of companies that you have, you're engaged with. How do you pick and decide what companies to advise or invest in?
Most of them, a couple of them were based on relationships, but that I've had over time. Most of them are really focused on what I think is interesting and where I think the world is going in the data space, and where I think there's potential for dramatic innovation. My sort of goal, and it's always been my goal as long as I've been in the industry, is to help people build systems to make their lives better and their jobs more effective. And, I feel like over time, I certainly look back on my career at places like Microsoft and Snowflake, where I know we did things, which really changed the way people work and really opened up, as I say, at Microsoft, SQL Server, Small Business Server, Windows Server, that opened the world of technology to literally a million small businesses around the world. Literally. And it was the only real cost-effective solution people had. And, with Snowflake, we solved problems that had been unsolved before. My goal is always to find, hard problems that are unsolved that really make a difference. And that's what I put my focus on.
And very innovative. So having talked about that, what advice would you have for our listeners wanting to grow their careers?
What I would say is be flexible. Listen, follow your instincts, but listen more than anything else. Try and listen more than you talk, and hear and understand, what the core issues are that customers have, and then really try and do something that's different and that solves it in a way that is unique and provides tremendous advantage to the customer. The places where, I always used to say, when I was at Microsoft, maybe let me say it this way, summarize it this way. This is probably as good a lesson as I ever learned. When I was at Microsoft in early 2000s, 2003, I took over Windows Server. And the meme going around in 2003 was that Windows Server was dead. It was going to get killed. And Linux was going to wipe it out. And of course, Linux was going to wipe it out because Linux was free, and it was just as good, except it wasn't free, and it wasn't just as good, at least in many ways. And what I said to everyone when I took over Windows Server, I said, look, people talk about Linux as a phenomena. I don't know how to stop a phenomena. A tornado, Hurricane Ian is a phenomena right now. That's a phenomena. I don't know how to stop Hurricane Ian. But I don't think Linux is a phenomenon. I think it's a product. And I think that our customers, Microsoft customers, our business, we're talking about business customers, they make decisions not based on phenomena, but they make decisions based on what's right for their business. And if we build a better product and price it cost effectively, we will win. If we don't, we will lose. And, and we then went and said, okay, what does that mean? And it's like, okay, how does Windows Server win against Linux? And your head kind of explodes for a second. And I said, well, let me think about the way I can understand it, which is Windows Server is used for a set of workloads. And, at one point we defined, I don't know, about 20 different workloads: networking, database, email, security, on and on, a whole series of business applications, a whole HPC, a whole bunch of different things that people tried to do with servers. And we went workload by workload, and we said, we said, are we world-class in this workload? And if we're world-class, we'll double down on the world-classness and we'll invest in the sales. If we're not world-class, we'll try and make ourselves world-class, or we'll get out of the market totally. And when I was still at Microsoft, from 2003 to 2011, when I left, we grew share of Windows Server
Mhm.
against Linux. Windows Server was like 74% share when I left Microsoft.
Oh, wow.
It's not 74% share anymore, but it's still pretty strong. It's still
Yeah.
shockingly strong, actually.
Yeah.
But the real key to this is that what matters is building the best product
Yeah.
and the best customer support, the best environment possible. And if you build the best thing, you win. If you don't, you lose. And I still believe that to this day in my heart of hearts. And that's what I focus on. I just got done talking to the Julia folks a few minutes ago. And I just, the summary on what they're doing is, keep making the product great. Keep making the product great.
That is fantastic advice. Thank you. So, Bob, we're going to wrap it up. One last question, which I asked my guest, and I'm waiting to see what you will say to this. Tell us something about yourself that the world does not know widely.
Well, I mean, I don't think the world, the world doesn't know that I have been working on for the last year or so. I've been working on a book that hope to come out in early next year. It's called The Datapreneurs, and it talks about the different great entrepreneurs in data that I've known during my career. And what are some of the lessons I've learned from them. Hopefully it's something people will learn a little bit if they read, and hopefully it'll be a reasonably easy read for somebody.
It's a leadership book, a leadership.
It's a business book. It's a business book around data, and it's talking about where data has come from and where it's going, and it provides a fairly unique perspective on that. And so it starts with my first datapreneur was Bob Epstein, who I worked with who was the chief technology officer at Sybase, and he really built Sybase, which of course is the foundation for SQL Server. And I thought what he did was amazing work, and I very much want to reflect that.
Amazing.
And go on, Bill Gates and on all the craziness we had at Microsoft.
I cannot wait to read this book. But thank you so much for coming on this show. This was absolutely an eye-opener discussion. Learned so much from your experiences, and hoping to continue our discussions. So this has been great.
Good.
Thank you.
Great. Thanks, Andy.
You're welcome.